Hello, my name is Arun Patwardhan. I am an Apple certified trainer with Evolve, which is an Apple authorized training center. As an Apple certified trainer, I teach people how to use the different Apple products to the fullest to get the most out of them. Apart from that, I also teach people how to support these devices in case they're helping others with the same. One of the courses that I teach is called as iOS app development. In this course, students learn how to make apps for the iPhone, iPad, or the iPod Touch. I will be talking about this course right now, and a little later I'll be giving you a sneak peek at the syntax involved, just to give you an idea about how this course goes ahead. But before all that, let me answer a few questions about the course and tell you what it is all about. So an iOS app development course is a programming based course where, as I mentioned earlier, students learn how to make different apps. Okay? This course requires prior knowledge of programming, preferably C++, C Sharp, or Java. Any language that has exposed the student to the object-oriented programming concepts, which are required before you do this course. There are many questions students commonly ask when they hear about this course. One of them is, do I need an Apple computer? Yes, you do. You need an Apple computer for this, preferably running the latest version of the OS, and you need a software called as Xcode. Xcode is an IDE which is freely available from the Mac App Store. You just need to download it and then you're ready to make your own app. Now, another question that students frequently ask me, do I need to have an iPhone? Do I need to have an iPad? Do I need to have an iPod Touch? No, it's not required. It is a benefit and a plus if you do have one, but to start learning how to make apps, you don't need it. You just need a Mac and you need Xcode. That is it. If you do have it, a little later if you do have an iPhone that is, you will be able to test the app that you make on the iPhone. Otherwise, you don't need one. How about the other things that are required? Commonly, when you're making apps, you need to be enrolled in a developer program. Apple has 3 developer programs. The first is called as the iOS developer program, which anyone can enroll for. It costs $99 a year, and what it really allows you to do is A, test your apps on devices, and B, upload your app to the iTunes store so that other users can freely download it. As far as this course is concerned, you don't need it immediately. You can delay your enrollment for a later period of time when you're ready to put your app out there. There is a second program called as the Enterprise program, which, as the name suggests, is for enterprise organizations, and it typically costs $299 a year. Under that program, organizations are allowed to make their own app and they are allowed to distribute it to their own employees internally only. You're not allowed to put it on the App Store. Again, this is something you can keep at a later point in time. You do not need it as far as the course is concerned. And lastly is the university program, which is meant for universities to test apps that they develop on devices as a part of the curriculum. A frequently asked question, can I learn this on Windows? It's not possible to develop iOS applications on Windows. You need a Mac computer itself. Okay? I have very little programming knowledge. That might be a little bit of an issue because some of the topics we deal with are more advanced. But other than that, nothing much. Simple requirements, 3 of them. 1, you need to have the programming background with the knowledge in OOPS. 2, you need a Mac with the latest OS. And 3, you need Xcode downloaded and installed on your Mac. Now we'll be looking at a little bit of how the course goes in through the syntax for Objective-C. Thank you. So let's talk about programming for iOS apps. As with all software development tools, you need to know a language to develop iOS applications, and that's called as Objective-C. Now, a little quick history about Objective-C. Objective-C was developed by Next Computers, and later on when that company was acquired by Apple, they acquired the language too. Today, Objective-C is the basis of both the Mac operating system, OS X, as well as iOS and all the applications developed on it. Now, as you're learning different languages, you realize that there are many things in common. And the same is true for Objective-C also. Objective-C actually incorporates a lot of C APIs and libraries. So you'll find that the syntax is very similar to C. However, there are always some differences. Like when you learn the first language, for example, C, and then you move on to say C++ or Java, you're going to discover that there are many similarities, but at the same time, there are some slight differences. What you really need to know when you're moving from one language to another is the differences. And the difference primarily lies with the syntax. If you look at it, the syntax for creating variables, for creating for loops is almost the same. The algorithms remain the same. The code logic remains the same. It's just how you implement it that changes. To get a good idea about where the syntax is really different, let's have a look at an example of a C++ class. I have a class called car with 4 public functions and 2 private variables. Something similar in Objective-C would look like this. Right at the top, you typically have the import, where you import the header files. Then you would have @interface, name of the class, followed by the class it inherits from. Now, one of the many things to remember in Objective-C is that each and every class has to inherit from another class. Unlike in C++, as you can see above, where inheritance is optional, inheritance is not optional in Objective-C. You have to inherit from another class. If there is no class for you to inherit from, then you can inherit from the fundamental or base class called as NSObject. Now, after this line of code, you typically have 2 curly brackets wherein you will declare all variables which are members of the class. This is where you're going to declare variables. Once you're done with that, you will then declare all the functions which are members of the class. And in the end, close off the implementation with an @end. This is how a class in Objective-C would look like as compared to C++. If we go to replicate what we see above, your variables would come out here. There you go. How about functions? Now the syntax for functions is pretty different. Whenever you talk about functions, you have 3 important aspects. One is where you declare the function, 2 where you call the function, and 3 where you implement the function. Now, as far as implementation goes, the syntax is not very different from C++, but the syntax is different for declaration and calling of the functions. A few things. You will often find the term messages used in place of functions. So typically we say that a particular class has so many message declarations. Now, how does the syntax look? Let us say we are looking at the implementation or the declaration, for the function getSpeed. Now, this is how the syntax would look like. It starts off with a minus sign, followed by int, which is the return type, followed by the name of the function. That's it. You can immediately tell that the differences are there. The return type is within parentheses, however the function does not end with a parentheses. How about the second function, void setSpeed? Okay, it's going to be fairly similar. A minus sign followed by the return type in parentheses, the name of the function, followed by a colon, the type of the argument within parentheses, and the argument itself, followed by a colon. Similarly, you've got the return type for the second function, followed by the argument type within parentheses, followed by number of passengers, which is the actual argument itself, closed with a semicolon. What happens if there are multiple arguments? Well, it's actually not too difficult. You just carry on like before. You've got the return type in parentheses, first the minus sign, followed by the function name, a colon, the argument or the type, the data type for the first argument, followed by the variable name. Now here's where it gets different. In C++, arguments to a function are comma separated, but here arguments to a message are not comma separated, they are space colon separated, followed by the type of the second argument in parenthesis along with the name of the variable itself, close with semicolon. And this way you can proceed all the way, adding as many variables as you wish. Now things get really interesting with the next feature I'm going to talk about. A problem common seen in programming is that when a function is called, typically you'll only find the actual data sitting in the argument field. So it's really difficult to tell whether the first argument is for speed and the second argument is for passengers or vice versa, especially if you're looking at code written by someone else. Now the way this problem is solved in Objective-C is by using something called as labels. Now what are labels? Labels actually are description for the arguments. And the good thing is the description is also present when you're calling the function. This makes the code very readable. Let me take the example that I just spoke about, setting the car values. We have a class called car and I want to set the values for speed and number of passengers. So how would I do it using labels? Simple. The return type still remains the same. I will keep the function name or the message name the same, and then I immediately start using the labels. So what is the first argument I'm sending? It's the speed. So I'll write speed, colon, close bracket or open bracket, integer, new speed value. Now here's where things get really interesting. The second argument will have its label immediately after the space. Num of facts colon open round bracket end close round bracket new num of facts values close. And that's it. You can immediately tell the differences between the first, this function on top and this one here. While they both will be implementing potentially the same task, one has to note that they are two distinct functions that cannot be easily replaced with each other. So you cannot declare a function like this and use the syntax for calling a function like this. They are not interchangeable. So that is something really important to keep in mind. And that is declaring functions. Let's look at the implementation of all this. Now, the implementation looks like this. You have the implementation file is typically called car.m. You've got .cpp as the extension for C++. Similarly, you've got .m in Objective-C. Right at the top, you've got the import for the header file, followed by, note that there is no parent class mentioned out here. How would you implement all this? Easy. I'm just going to copy the code here for simplicity. Return speed. As I said, the implementation is not very different from C++. Out here, for example, I would have something like this. And that's it. And you can similarly go ahead and implement the other functions. The syntax is fairly easy, barring a few tweaks here and there. You'll find that it's rather easy to learn and start using, and honestly, fairly addictive too. And the same thing would actually come down here. So I do this, I actually have this. There you go. So this is how a typical .m would look like, and always remember that a .m closes with the @n. Now for those of you who are really concerned about all this, you needn't be. I mentioned that the tool required for making apps is Xcode, and Xcode is really helpful. What it allows you to do is design code easily and quickly. So if you want to make a class, all that you have to do is file, new file, Objective-C class, mention the name, mention the parent class, and that's it. A large part of your syntax will already be waiting out there. All that you have to do is fill in the details such as variables and the member functions and things like that. So you don't have to worry about each and everything. Though of course it is always good to know. Now that we've looked at declaration and implementation, let's look at the most important aspect, which is calling. Now, a small thing to keep in mind. All Objective-C objects are actually created dynamically. There are no locally created Objective-C objects, which means you should be good at pointers. Okay, that's something small to keep in mind. Let's proceed ahead. So let's say I have a pointer for a class called newCar, which I've created, and I wanted to call the function setSpeed on it. Now normally your C++ syntax would look like this. New car dot set speed, and you'll give a value of say 25 and close bracket, done. By the way, I'm assuming that it's not a pointer. If it is, you would have something like this. However, in Objective-C, new car is a pointer, so I'm going to talk about that. The function call always in Objective-C starts with a square bracket, followed by the receiver of the message. Remember what I said earlier, functions are often referred to as messages in Objective-C, and each message has a receiver. So the receiver in this case is new car, space followed by the name of the message, set speed colon 25. There you go. You can immediately tell that the syntax for C++ is very, very different from Objective-C, and as a developer it's a huge asset in a way. You can immediately distinguish between a C API call and an Objective-C API call. As I said, there's a lot of C code available, and you will be using that quite frequently in your apps. How about the get speed? Well, in Objective-C it's going to look like this. New car arrow get speed in C++, sorry, in Objective-C, int value is equal to square brackets new car get speed. How about that function with multiple arguments? Not at all difficult. New car set car values colon 25 space colon 5. Now you can immediately tell that there is no way for you to find out what 25 and 5 represents. Is the first thing the number of passengers, or is the first thing the speed of the car? You can't tell. So what do? We make use of the second function that we had designed, the one with labels in it. And then you'll notice it becomes just like reading a sentence. Set car values. Which values? Speed as what? 25. Number of passengers as what? 5. There you go. Of course, the concept of labels doesn't exist in C++, but if you had to do something similar, especially the set car values, 25, 5. There you go. And you can immediately tell that this is far more readable than this. It conveys a lot of information and it makes programming a lot easier. And this combined with Xcode's feature of auto-completing what you're typing, things get very, very easy. The chances of error really go down. There are a lot of benefits from this. A, you can easily distinguish between Objective-C and C code. B, the syntax makes the code really readable. C, the fact that Xcode is there to help you at every step, and by the way, it's a tried and tested tool. App development becomes really, really easy. And that's one of the major changes in syntax for Objective-C. We've looked at how to declare functions, we've looked at how to implement functions, and finally we've looked at how to call functions. Thank you.